Alrighty, so last time we were multiplying, dividing. We've done a lot of those things already. So today we move on to adding and subtracting polynomials. And I think we've done this before, so let's just do a little warm-up. Look at this first expression. Simplify. X plus 2 plus x plus 2 plus x plus 2 plus x plus 2. Oh yeah, you get the picture. So let's see. We're going to simplify that. So how many x's do we have together? Let's see, there's 1, there's 2, there's 3, there's 4, there's 5, there's 6, there's 7, there's 8. There's 9 of them. And also, how many 2's do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So really we have x plus x plus x. And we have 9 of those. And then we have plus another 2 plus 2 plus 2. We got 9 of those. So it looks like we really have 9x and 9 2's make 18. So that's what our expression comes out to be. And you may have said, well, why don't we just combine like terms? Well, let's talk about like terms. Great. So if you look at this, the second one here, 12x squared plus 5x squared, and we say that equals 17x squared. So they are like terms. Explain. How come? Well, what makes terms like terms? What do the 12x squared and the 5x squared have in common? So we're going to say that they have the same variable and the same exponent. So as long as that power is the same, the x squared is the same in both, we can combine them. Because 17x squared, I mean, if you want to even backtrack a bit, can we say that we have x squared being added to 12 and 5? So that's where we get our 17x squared. That allows you to combine the like terms. Our next question, why are 12x squared and 5x unlike terms? I think you can tell that the exponent is missing. So they have different exponents. Are 3ab and 11ab like terms? I mean, we got a's and b's, but are the variables the same and are the exponents the same? They are like terms. Yes, indeed. How about 12x squared and 5y squared? Same exponents, but they're not because they have different bases, different variables. And finally, 12x squared and 12x. I mean, same coefficients, they're both 12, same variables, but no different exponents. So to summarize, like terms, they have the same variables and the same exponents. And if we have like terms, we can combine them. So let's combine a few. And yes, we're going to talk about like adding and subtracting. So you can kind of think of this first one as add the binomial 4x squared plus 5 to the trinomial x squared minus x minus 6. Notice a little bit of the vocab there too. The first one's a binomial, 2 terms. The second one's a trinomial, 3 terms. So we're going to add those 2 polynomials together. So let's combine our like terms. I have a 4x squared and x squared. Well, the coefficient of the x squared is 1, so that's going to give me a 5x squared. I don't have any x terms except for the one on the right, so I'll bring that over, a minus x. And then we combine that positive 5 and that negative 6. 5 minus 6 is negative 1. Don't say 11. Don't say negative 11. Things like that. It's a positive 5 combined with a negative 6. If you're using your calculator, it's 5 subtract 6, not 5 minus negative 6. That 6 is negative, so it's a positive 5 combined with a negative 6. Glad we got that out of the way. Let's do the same thing. Let's combine our x squareds. Here's another example, a 3 and a minus 4. That's going to give us a negative 1x squared. A positive 5x and a negative 5x. Oh, let me go back because I wanted to put those in a different shape than a circle. Let's put like a box around that one and a box around that one. I'm going to kind of box my like terms together. A positive 5x and a negative 5x, they make a 0x. And yes, you could just eliminate that completely if you want. I'll rewrite it. And lastly, we have a -4 and a +2. They combine to give you a -2. So if you want to write your answer as -x² minus 2, that's beautiful. One last one here. So we have a 7x to the third y squared and another 7x to the third y squared. Those are like terms. I have the same bases, same exponents, same variables. Things look good. So if I combine their coefficients, I get 14x to the third y squared. And likewise, let's combine the other ones. And yeah, I did it again. I drew another circle. Let's combine the xy squareds. And I have a -5 xy squared and a +5 xy squared. That gives me 0 xy squareds. So I'm done. 14x cubed y squared is my answer. So addition is pretty straightforward. You're just really combining like terms. Oh, but what happens if we have to subtract polynomials? Oh my goodness. Well, you probably remember the old keep, change, or distribute the negative through. So this really then becomes 5x minus 3. And if I distribute that negative, I get a -7x and a -2. Can you now combine like terms? Of course you can. And that's going to give us a -2x minus 5. Again, a -3 and a -2 make a -5. And our last one, I think you got the idea now. We're going to distribute that negative through. And that's going to give us a +3x squared, a -2x, and a +6. I'll bring down my other polynomial. And now let's group together our like terms. I have 5x squareds total. I have a -7x. And I have a +12. So with that negative, you're just really going to distribute it through, change the signs, and then combine your terms. Ooh, just let's be careful of this subtract from phase. If you're subtracting 5x squared minus 4x plus 3 from 7x squared minus 4x minus 3, which one goes first? Yeah, you're right. 7x squared minus 4x minus 3. Now don't be lazy here though, because you're subtracting the other polynomial. So set it up so you can do your distributing. Don't be lazy on me. So now we distribute that negative sign through. We're going to get a -5x squared, a +4x, and a -3. And if I bring down my first one, combining terms, I'm going to get a 2x squared. I'm going to get no x's because -4 plus 4 is 0. Subtract 6 because the -3's combine the -6. So the big thing here is to distribute the negative through. And if you're given a phrase like subtracted from, make sure you put them in the right order. And that's all, really. Do you remember some of the things we've done so far? This is kind of just like the overall refresher. I'll start at the bottom one. This is what we just did. We want to combine like terms. And do you remember when you multiply monomials? We said keep the base and add the exponents. For powers, you got it. We keep the base. But this time we multiply exponents. And our final one, when we divide, it's the inverse of multiplying. So while we keep the base, we're going to subtract the exponents. Those are the rules that we've done for the previous few lessons. Again, the new one today is this last one. Maybe it's not so new because you're really good at it already, but we're combining like terms.